Welcome back, viewers. Today, we are going to explore the fascinating world of trusses, an important aspect of engineering and construction that has been used for centuries to create strong and efficient structures. Trusses are an essential part of many iconic structures, such as bridges, towers, and roofs, and have played a significant role in shaping the world around us. In this video, we will delve into the history and importance of trusses, the fundamental concepts of truss design, and the various types of trusses commonly used in engineering. We will also cover the design process of truss structures, including the steps involved in creating a truss, selecting appropriate materials, determining load requirements, and designing members and joints. Additionally, we will examine case studies of truss structures that have been designed and analyzed using the methods discussed in this video, providing real-world examples of how trusses are used in different types of structures. So, whether you are a student, a professional engineer, or simply someone who appreciates the beauty and functionality of structures, this video is for you. Join us on this journey of discovery as we explore the creation of the truss. The truss. Truss structures have been used in construction for centuries, dating back to ancient civilizations such as the Egyptians and Greeks. However, the modern concept of the truss structure was developed in the 17th century by mathematician and physicist Robert Hooke, who recognized the strength and stability of interconnected triangles. Truss structures are important in engineering as they provide a lightweight and efficient means of supporting large structures such as bridges, roofs, and towers. They can also be used to reduce the amount of material required for a structure, making them more cost-effective and sustainable. The objective of this thesis is to provide a comprehensive overview of truss structures, including their design, analysis, and various types. The research questions that will be addressed include: 1. What are the fundamental concepts of truss design, including the geometry and stability of a truss, the types of truss members, and the methods of analysis? 2. What is the process involved in creating a truss, including selecting appropriate materials, determining load requirements, and designing members and joints? 3. What are the various types of trusses that are commonly used in engineering, including the Pratt truss, Warren truss, Howe truss, and others, and what are their advantages and disadvantages? 4. What are the methods of analyzing truss structures, including the method of joints, method of sections, and computer-based analysis methods, and what are their advantages and limitations? 5. What are some case studies of truss structures used in different types of structures, such as bridges, roofs, and towers, and how were they designed and analyzed using the methods discussed in this thesis? By answering these research questions, this video aims to provide a comprehensive understanding of truss structures, their design, and their analysis, which can be used as a valuable resource for students and professionals in the field of engineering. Truss fundamentals. Truss design involves the creation of a structure that can support loads while maintaining stability and minimizing material use. The geometry of a truss is based on a series of interconnected triangles, which provide strength and stability. The types of truss members used in a structure can include tension and compression members, such as bars or cables, and may also include diagonal members to provide additional stability. The stability of a truss is based on the concept of equilibrium, where the forces acting on the truss must be balanced to prevent any movement or collapse. This means that the sum of the forces acting on the truss in any direction must be equal to 0. Various types of loads and forces act on a truss, including dead loads, which are the weight of the truss and any permanent fixtures attached to it, and live loads, which are the weight of people or objects moving across the truss. Other loads and forces can include wind loads, snow loads, and seismic loads. Methods of analysis are used to determine the strength and stability of a truss structure. The method of joints involves analyzing the forces acting on each joint of the truss, while the method of sections involves cutting the truss at a section and analyzing the forces acting on that section. Computer-based analysis methods, such as finite element analysis, use numerical methods to calculate the stresses and strains on a truss. Truss design. The design process of truss structures involves several steps that must be taken to ensure the truss can support the expected loads while remaining stable. The following are the steps involved in creating a truss. Considerations that need to be taken into account when designing trusses for different types of structures include: types of trusses. Trusses are commonly used in engineering for their ability to efficiently support loads over long spans. There are several types of trusses that are commonly used, each with its own unique characteristics and advantages. The following are some of the most common types of trusses. Case studies. Case studies of truss structures provide valuable insight into the design and analysis methods used to create efficient and effective trusses for different applications. The following are some examples of truss structures that have been designed and analyzed using the methods discussed in the previous chapters. Conclusion. In conclusion, trusses have been an integral part of engineering and construction for centuries. From the humble wooden trusses used in ancient roof structures to the complex steel trusses of modern-day bridges and towers, trusses have proven to be a versatile and efficient means of supporting structures and distributing loads. The creation of a truss involves a careful design process that takes into account the materials used, the load requirements, and the forces acting on the structure. Through the use of mathematical modeling and advanced analysis techniques, engineers are able to create trusses that are optimized for their specific applications. By studying the history, design, and analysis of trusses, we gain a greater appreciation for the intricate and beautiful structures that make up our built environment. From the iconic Golden Gate Bridge to the innovative cable net roof of the London Olympic Stadium, trusses continue to play a vital role in shaping the world around us. We hope you have enjoyed this video on the creation of trusses and gained a deeper understanding of their importance in engineering and construction. Whether you are a student, a professional engineer, or simply someone who appreciates beautiful and functional structures, the truss is a fascinating subject that is worthy of further exploration. If you enjoyed this video and want to see more content like this, please consider subscribing to our YouTube channel. By subscribing, you will be notified when we upload new videos on a variety of topics related to engineering, science, and technology. Don't miss out on the latest updates and insights from experts in the field. Click the subscribe button now and join our community of like-minded individuals who share a passion for learning and discovery.